Hey everyone, welcome to synthetic division. Long division was the first video. It actually took a little bit to explain. My students usually ended up getting it eventually, like, oh, this is really just a matching game. Okay, I can do long division, even though it's kind of a lot of writing. I said synthetic division on the easy ones, synthetic division is definitely better. On the harder ones, maybe not so much. So it's nice to know both. Synthetic division is a little bit easier if set up correctly. I'm really sorry for this, by the way. I'm not at school plugged into my smartboard, so that's just going to be part of it. So, how to use synthetic division? Press pause, write these down. Okay, now that you got them written down, I'm just going to show you what's up. Okay. Oh, man. Zoom this. There we go. So, example one, we did it by long division. This should look familiar. Um, then we did synthetic division. I said, here's what happened. First of all, synthetic division only cares about the numbers here in front. 2, negative 13, 26, negative 24. Boom. Second, we're going to use this negative 4 over here. You notice the sign has changed. If you remember back in long division, we had a subtraction moment. And our subtraction moment was we're going to change these signs and then combine them together. Well, changing the sign right here from what you saw right here, that is our subtraction moment. We don't ever have to worry about it ever again. Otherwise, we would be doing a ton of subtraction. So anyway, this is how it works. Hopefully, hopefully you can kind of figure it out. Give it a second. I'm pause the video, see if you can't figure it out. So that's your unpaused. Hopefully you realize if you go, especially if you went back to the instructions, the 2 drops. This first number is always just going to drop. 2 times 4 is 8. That goes there. These then combine to give me a new bottom number. Then as bottom number times the box gets me negative 20. They combine, new bottom number, bottom times box. Over here, boom. This last column is always my remainder. And then we just work our way up from constant x, x squared, x to the third, x to the fourth, x to the fifth, and so on until we run out of spots. So basically, we started with x to the third. We ended with x squared because we took out an x. So each of these exponents should be one smaller. Well, how do you get one smaller than a constant? That's why it's the remainder. So everything's one smaller than what it was originally. But if you just think, okay, my last column is my constant or my remainder, then it goes constant 1, 2, 3, 4. 2, negative 5, and 6 become 2x squared, negative 5x plus 6, no remainder. Synthetic division, find this. 2, 3, negative 4, 15. And instead of positive 3, we use negative 3. 2 drops, multiply, become negative 6. Combine, multiply, become 9. Combine, multiply, negative 15. Sweet, no remainders. There's my constant x, x squared. There's my final answer. Again, I might be going fast. Pause the video if you need. Once you kind of see what's happening, it's usually easy. I did all this in one color because my students were like, yeah, I think we got this. So again, 3, 2, 1, 0. So 3, 2, 1, 0 became 2, 1, 0, and remainder. Drop the 3, multiply, combine. And again, negative 2 becomes positive 2. That is my subtraction moment. Otherwise, each one of these would have to be subtraction. So, combine, new number, combine, new number, no remainder. So we're good to go. So what happens here? Oh boy, we are missing a to the third. I actually posed this one as a challenge to my students. I said, okay, you guys are so smart, do it. And of course, they all did it like this. And I did it like this. And I said, how many of y'all got this? And a bunch of them raised their hand. I said, you're wrong. And in each one of my classes I had, oh man, I knew it. I knew it was supposed to, because we talked about the placeholder with the long division. If you don't have a variable, you got to have a placeholder. Each one of these represents a certain column. Because look, here's the deal. A to the fourth, and you divide by A, and you get, and I'm sorry, I used X. x. X is just a habit. It should be a. You get a squared. A squared times this a is going to get you back to a to the fourth? No. That's why this should be x to the third. And then if you do that, you would get x to the third squared, 1, and then constant. And it's like, wait a minute, this should be my remainder. You should have a whole bunch of red flags. So here we go. 0 there. We actually do get a crazy remainder, 92 over the a plus 2 that we remember with our remainder. It's whatever it is divided by whatever we were trying to divide by in the first place. So that's what it should look like. Please do not forget your placeholder. This is one of the things about synthetic division, or really division in general, that will trip up a lot of people. Now, the only thing about synthetic division, whatever you're trying to divide by, that front number here has to be 1. Let's go back. That a had a 1 in front of it. That x had a 1 in front of it. I wrote a 1 in front of that x. That x had a 1 in front of it. We haven't worried about it up till now. It's an issue. Okay, we cannot have that to be 1 or have that to be anything other than 1. So we have to divide by 3. We also have to divide this by 3. We also have to divide everything by 3, which means, as you can see over here, fraction. Now, if it's a nice, and this one wasn't even too nice, but usually these fractions line up pretty well. The 1 drops, because now I got all this over here. 1 drops, negative 1/3. -5 and -1 make -6. Common denominator, divide by 3, and get -2. You can see I get whole numbers as I do this, except for my remainder. My remainder, as we learned before when we had a fraction remainder, is just -2/3, and then the x plus 1/3 go down here. We are not dividing by this anymore because we had to change everything in order for synthetic division to work. Now what happens is when we distribute 3, we actually get back to the 3x plus 1. Remainder constant x squared, x to the third. Is x even the right variable? I'm really sorry if I don't use the right variable. It's just a habit to use x. Now I also want to say the 0 could potentially be missed if you're not looking for it, because this is our constant. This didn't have a constant. You gotta be careful. Whatever your highest, count all the way down. If it's 7, then you need 7, 6, 5, 4, 3, 2, 1 constant. Otherwise, it's not going to work. 3 minus a. And again, I originally wrote it with the -1. It's still the same as divide, not a big deal. 3 minus a became -a plus 3. We had to switch these around. And then this has to be +1, so we need to change the signs there and there, which means those change also. Which means here in red is what we're actually looking for. This one should look familiar. We've done this now, I think, 2 or 3 different ways. Remainder is still -19 or -19 over the a minus 3 that we have. Again, make sure you change from minus to plus or from plus to minus. If you don't, all your stuff's wrong. It's that simple. Oh, that's an old one. Ignore that. This one was also part of the worksheet from when I was gone. So there was no book work for this particular one. So hopefully you at least tried that in class, because I think that was one that could not be made up.